So good day everyone. You are welcome to lecture online. So today we'll be starting on the topic motion. Motion. So what's the definition of motion? What is motion? So he said motion is the change in the position of an object or a body with time. Motion is the change in the position of an object or a body with respect to time. So, when we talk about motion now, for instance now, this is me here. I'm at a particular position. I want to change my position now for at least 3 seconds. If I take the first step, first, second, third. What has occurred? Motion has occurred. Because why? The position of my initial body there has what? Changed. With what? With respect to time. So that is what motion is. The change in the position of an object or a body with respect to time. So a quick one. We have equations we use for calculate for equations of uniformly accelerated motion. We have equations. Quickly, I'll write it out on the board. So you can put that down in your journal and your notebook. Equations for uniformly accelerated motion. So a quick one, equations for uniformly accelerated motion. The first equation is V equals U plus AT. The second equation is S equals UT plus half AT squared. Then the third one is V squared equals U squared plus 2AS. So these are the three major equations we use for uniformly accelerated motion. But we have one more. Let me add that one to it. So the first three I wrote on the board now are the three major equations we use. Three major ones. But based on the textbook you might have used in studying, some textbook listed out these 4 equations, while some textbook just these 3 equations. Equation is V equals U plus AT. The second, S equals UT plus half AT squared. The third equation, V squared equals U squared plus 2AS. And the last one, S equals U plus V over 2 times T. So quickly, let's divide the terms we have in these equations. I think we are having 4 terms. V, U, A, T, S. Okay, there are 5 terms. So quickly, where our V, okay, let me list it out here. Where V equals my final velocity. My final velocity. Of course, we know final velocity in meter per seconds. My U is the initial velocity. Meaning the velocity at the starting point, initial velocity, also in meter per seconds. What again are we having? My A is the acceleration. Acceleration in meter per second square. Meter per second square. Also, I'm having my T. T. The T is the time. So my T is the time. And we all know that time is in seconds. Quickly, let me quickly say something about this T. Most of them find it kind of confusing when it comes to T in physics. Now we have capital letter T in physics and we have small letter T. Small letter T is for time. The capital letter T can be for your temperature and it can be for your period when it comes to wave and oscillation, your simple harmonic motion. But anyway, you see small letter T, T is for time and time is measured in seconds. Then lastly, my S. S is the distance in meter. Distance in meter. So quickly let's run through the equations for uniformly accelerated motion again. We said the first one is v equals u plus at, where my v is the final velocity in meter per second. My u is the initial velocity also in meter per second, because it is velocity also. A is the acceleration in meter per second squared. T is my time in seconds. Then lastly, S is my distance in meter.